move a little quicker to get to the cool stuff, the cooler stuff. Yeah, he's got lots of extra slides. Okay, so we have, after all this microservice talk and Camel and the demo, even in your real environments, you can say, well, we have Camel, we have all this, but my head still hurts when we try to do this microservice thing. And let's look at some of the problems that you're going to run into that typically would run into when you are developing. As a developer focus, what are we looking at when we develop microservices? So if you have one application running it on your laptop, you build it and you run it and you make some changes to your code and build it and run it again and so on. But in a microservices world, you may have 2 or 3 or 10 different services that you may depend on or collaborate with, that you or you have message queues and different databases and so on that you want to run locally as a developer. So how do you do all that? What if all of those apps, all of those services listen on port 8080? How are you going to run all those? Trying to go in and change and figure out, do I change it over here? Is it port 8081? Oh damn, this one's already 8081. That gets me a nightmare quickly. How do we package that? When we talk about, we saw in this Camel example, we use the Camel main directly. In the community, we informally call this Camel boot, but it's just a bootstrap process for Camel. If you use that, or if you use Spring Boot, how do you package all of the dependencies of your application? I mean, when you take the main dependencies and squish them all into a single jar, that's one aspect of it. But Java applications run inside of a JVM. That is an intimate detail about the application. That is a very hard dependency that has to be there. Switching between JDK 1.6 and 1.7 and 1.8 could potentially break your application. The way you tune the JVM to run in a machine is very dependent on the JVM that you run. Those JVMs depend on native libraries, C libraries and glibc and all that. How do you pack it? If you're going to take a service and you're going to build it on your laptop and expect it to run the same way in QA or prod or wherever, how do you package all of those dependencies together? How do you test them when you have a lot of microservices? How do you test them? How do you do process isolation? So, like I said, going back to the JVM real quick, the assumption of a JVM, when you tune it for garbage collection, is that the threads that it has and the CPU that it has access to and the way you're going to tune the garbage collection is under the assumption that it's the only thing running on the box, that it has full control and full access to the CPU. If you start running more JVMs on a single machine, that premise is no longer true, and you may or may not get the GC behavior that you want. Or one JVM, one app, and one JVM decides it's going to use 100% of the network item, and that solves any of the other apps working on that machine. So how do you do isolation of these services? When you start to build them out, how do you discover them when they're elastic and they're failing and they're coming back and all that stuff? And you have multiple versions. So all of this stuff, as a developer, to wrap your head around gets more daunting. Now, if you're on the other side, and you're thinking about, well, how do we actually run these? And you maybe already have a shared infrastructure team, so a team that deals with a lot of different teams. Do we run each team in a separate JVM, in a separate VM? That's going to be a lot of overhead. So how do we collapse things? How do we share things? And how do we get the isolation that we want? And we think, well, this JVM has this class loader that makes it look like it's isolated, but at the end of the day, it's just still one process. So how do you get multi-tenancy in a single JVM? You can get it to the degree that some packages are exposed or not, but at the end of the day, it's still just one process. So what are some reasonable solutions for this? Being able to move a lot of services and deploy a lot of services and manage a lot of different versions and service discovery and load balancing and failover and all this stuff. You can rely on automation, and that's good. Automation is good. Things like Puppet or Chef or Ansible rely on templates and versioning, source control management to be able to roll back changes as you need. Fuse Fabric thing, ignore that for now. But what we want to be able to do at scale, we start talking about microservices at scale, what we want to be able to do is deploy our application at scale, but not have to worry about each individual virtual machine that it's running on. If something behaves weird, then, you know, you guys heard the pets and cattle analogy? No? Okay. So the way you want to look at it is the same way a farmer might look at a herd of cattle. The cows aren't given individual names. If a cow is sick, they typically don't try to nurse it back to health. They have thousands and thousands and thousands of cows, and shoot the cow and get another one. But as a pet, you're probably not going to, you love your pet and you nurture your pet and it has a name and you care for it. If it gets sick, you take it to the vet. So the difference in how, and if your servers have names and you're caring for them and you're patching them and you're loving them, that's more of the pet model. If you're Google and you're running Gmail in an environment where there's 1,000 nodes, if one node is misbehaving, you're not going to try to figure out what's wrong. You're going to log in, see the exception, the stack trace, and all this stuff. You're just going to blow it away and start up a new instance. And the reason is, if you have thousands or hundreds of thousands and you got these gigantic fleets of microservices and things are getting smaller and smaller, having to manage each individual one of them becomes almost impossible. So treat them all the same, and if things start going wrong, then just replace them. Any questions about that mentality or that thought? So instead of trying to manage each individual detail and component as a pet, what we want to be able to do is build out and deploy a fleet of applications, but we want to do this in a safe way. If you look at the way companies typically will deploy Java applications today, is the developers will say, here's my source code, and maybe a build system does a build, and you end up with a here or a war or a jar or whatever, and then maybe you go open a ticket that says, hey, copy this here into an application server that you have that may be the same version that I use, and it might be the same operating system that I used, and change this environment variable over here, copy this config thing over here, and then change the JVM parameters to be this, and hope that it works. When you're doing that at any kind of scale, and with multiple pieces, that becomes prohibitively expensive and almost impossible to do. So what we want to do is build our application so that we don't have to worry about fiddling and putting jars here and bouncing servers here and all this stuff. We want to say, here's our image, here's our application with the JVM, the ears, the wars, the jars, whatever, the JVM's dependencies, the configuration, and I'm going to run it here, and it should, this golden image shouldn't change when I move it to a development environment, and then we're going to migrate that to a QA environment, and then ultimately to production, so that you know what you test. I mean, that's the whole idea, is to have environments exactly the same, so that when you test it here, you know that it's going to behave the same in a higher environment. So that image, that way of capturing your application and all of its dependencies, is a way of doing what's called immutable delivery, immutable deployments, where we create an image and we treat it like cattle. We say, go deploy it, scale it up, 1,000 nodes. If something fails, blow it away and restart another one. It should behave exactly the same. And if you had a new version, if you make changes to your code, then don't try to in place, hot deploy and change things around. Just blow away the old versions and start the new versions. And that's exactly what Netflix is doing, I don't know where they are now, but was doing with AWS. doing this kind of immutable deployment is typically difficult with VMs. Doesn't have to be, because Netflix did this inside of AWS, because AWS provided APIs that can be scripted and automated for actually building these VMs. And what they would do as part of their build lifecycle is build an image, a VM, AMI, that would have their application, their dependencies, and all configuration, all that stuff, and then that's what they would deploy. And if they had changes or versions, they would build a new image and replace whatever was running in production, or run it alongside, or however they did it for whatever scenario they had. So this is where Docker comes into play. Who's heard of Docker? Raise your hands if you've heard of Docker. Okay. How many people use Docker in a production environment today? One? Awesome. How many people use it in a development environment? So Docker brings a elegant solution to immutable delivery of an application. I think in the, so I have the other one. So Docker isn't, the underlying technologies in Docker aren't earth-shattering or new. They've been around for at least 10 years, 9 years or something. So it's built into the Linux operating system. And it uses a couple of kernel features that allow you to make a process, so think JVM, think that it's the only process in the machine, that it's running on its own machine, that it has access to its own CPUs, its own memory, and totally isolated. But the beauty of Docker, so for isolation purposes, is now you can run a bunch of JVMs on a single machine without the overhead of actually having to have them all in VMs, because they're all just processes. They're all Linux processes, and they've been isolated in such a way that if one process goes awry, who cares? It doesn't impact the other processes. The other aspect to Docker that comes into play with the images is that it's based on the image that gets created is not a fully baked VM. Like I just said, these are just processes that get run. But each layer in that image specifies what's actually running inside of that container. So if you make a change to the container or to what gets run, the application, you're really just changing out the top few layers of the image. Whereas at Amazon or a VM, if you want to create a new image, you have to create an entirely new VM. So you could think of the lower levels of the image to be a base image, like a rel. And then on top of that, you may add your application server, and on top of that, you may add your application. But so when I make a change to my application, only that top layer gets changed, not everything else below that. Does that make sense? So when I deploy this out to my hosts, my Docker hosts, I'll send, there's going to be one big bang, and I'm going to send all the layers out to the Docker host, but now when I make changes, I'm just sending out the smallest top layer. So what do you run Docker in production? How do you guys, do you run it on multiple hosts? So right here in the front.
I don't deal in it directly. We've got some more DevOps team members that are more hands-on with it.
Yeah.
And it's kind of a moving target.
Okay.
Also, we're learning as we go a little bit.
Okay. So when you run Docker on a machine, you can quickly start up an application, but then it's, like I said, it's still just a running process on that machine. If it goes down, how do you know that it went down? If you want to start up more copies of this, do you log into the machine and say, hey, give me, manually start up 5? How do the applications within Docker discover and talk to each other that are running in different containers? If containers start to go down, how do they know that those containers went down? And to, get HTTP 500 or IO exceptions when they talk to them. So how you place Docker container, now this is just on one machine, but you can take this across multiple machines, that gets compounded. So what you need is some way to start Docker containers, decide where to put Docker containers. If those containers go down, restart them, allow those containers to interact and talk with each other. And that's what Kubernetes does. Kubernetes is an open source project that was originally started by Google, that Red Hat is now heavily invested in. We're, I think, the second leading contributor to Kubernetes. But what Kubernetes is it's a third generation manifestation of what Google uses internally to build and run and manage containers in what is the number? They start 2 billion containers every week. And they don't use Kubernetes, they use their own Frankenstein thing that they built over the last few years. But Kubernetes is the next iteration of that. They've taken all of the lessons learned, the sharp edges that they've experienced with what they call Borg, is what they use internally, and said, let's start from scratch as if we could just know everything ahead of time and build it the way we should have built it to begin with. And this is what they've come up with. So in the Kubernetes world, what I love about Kubernetes is that the concepts, there's only a handful, like 4 really, that you really need to know. But the concept seems simple. And this is probably evident of Google having known ahead of time all the steps not to take. But they've made something that does pretty complex stuff and made the concepts quite simple. So in Kubernetes, we have the first concept that you want to understand is a pod. So a pod is the lowest unit of abstraction that can be scheduled or run on any one of these hosts. It usually maps one-to-one with a Docker container. So you can think of a pod as being a single Docker container, and that's what Kubernetes runs on these machines. It's not exactly a Docker container because you can run multiple Docker containers within a pod. You would do something like that for, maybe you have your web server that's generating all these logs, and maybe you want a side process that reads those logs and maybe ingests them into Splunk or Elasticsearch or something. But you want that application to always be running co-located with your web server. So it's a way of forcing affinity of containers to always run together. So that's a pod. A pod is just, think of it as a Docker container. The second concept that is it in here? It's not. The second concept that you'll want to be aware of is the replica controller. So, as I was mentioning, how you run Docker containers inside of a host, what if you want to run 5 instances of the same Docker container? Or 1,000, like we said Google does, and if one goes down, just blow it away and start it over. So in Kubernetes, the replica controller controls the number of pods that are actually running and where they're running. The third thing you want to know is that pods can be labeled with simple key value pairs, and they can have multiple labels. And you would label them, and here's an example. You would label them to be able to group them and slice and dice them in different ways, different different ways you organize your infrastructure. So you could label a pod as, here, this is version 1, or this is the JVM application, or this is the Node.js application, or this is the database, the back end, or the front end, or the middle tier, or whatever. Now, when your replica controller is saying, I want 3 of this type of application, you specify that by saying, I want the replica controller to control a group of pods that have these labels. So you can use selectors and select groups of pods that can be managed with that replica controller. So if we say, build a replica controller with n equal production, that might be all of the production applications, and we say we want 1,000 of those, then a replica controller will go in and scale up all of those pods to equal 1,000. Or we want to bring it back down to 10, it'll go and kill off 999 90 of those and bring it all the way back to 10. The last thing we want to know is services, Kubernetes services. This is the mechanism that allow pods to talk to each other and discover each other. Even if pods start crashing and going down, they can still, as long as there's one left, they can still talk to each other through this concept of a service. You can think of a service as a virtual IP to a group of pods, sort of like a software load balancer to a group of pods, and that IP never changes. And on top of that, you can run DNS inside of Kubernetes to point to that one IP and do service discovery. Usually DNS for service discovery is not a good idea, but because this IP never changes and will always load balance across all the pods in that cluster, an application can always use a service to talk to another application. Yes, sir?
Is node a logical separator, or is it really representing a host here?
Is it a logical separator?
So here, when you say node on one block, that is a host?
Sorry, yeah. Yeah, node, these are two different, they can be physical hosts or they can be virtual machines, it doesn't matter. But they're two different Docker hosts. This is where the Docker containers are running. The Kubernetes components also run on those hosts. And this little kubelet is sort of a controller that says how many, or what Docker containers should be running on this host, and how many of those, and what service abstractions do we have, and it manages all that stuff. So if this group of pods, you know, an application here, let's say it's a REST application, wants to talk to a database application, it would talk to a service that knows how to find those database applications, and it does that also by using label selectors. So we can say we want to talk to the MongoDB databases, we'll find the ones that have been labeled with MongoDB. And when the REST application talks to the backend, it talks to this service IP, you know, that cluster IP, that virtual IP that's static, it's fixed, never changes to the life of that server.
This should work very well for application, but for database, what about the file system infrastructure that it's sharing? How do you guys replicate? How do you guys do that?
Well, how it gets replicated, it depends, because your database can have replication at the application layer. If you're talking about the storage layer, so that is a part that Kubernetes, it sort of differentiates itself from other cluster orchestrators, in that they've thought that through. There are volumes and persistent volume plugins that you can use that'll map into your pods. So for example, if you have, let's take MongoDB. MongoDB has journal files and transaction files and all that stuff. Those have to live somewhere. That, where it lives, it can't live inside the Docker container, because if a Docker container goes away, then all that stuff, all that data goes away. If the pod goes away, same thing, it doesn't keep anything. But Kubernetes can map in storage. Let's say it's NFS, or let's say it's Elastic Block Storage from Amazon or something. It can map in the storage to that pod, regardless of where the pod is running in the cluster. So if that pod goes down, and then the replica controller brings it back up, it'll remap those volumes back to the pod. So you don't have to try to figure out, is this on host 1 or host 3 or host 5 or wherever. Kubernetes will manage the persistent volumes for you. Any questions about that? I know I went super quick. I want to get to the CI/CD stuff. Oh, damn, we're running out of time. Okay, so OpenShift is Kubernetes for enterprises, and has a lot of developer self-service tooling built on top of it. Okay, and when I say Kubernetes for enterprises, you're probably like, what the hell does that mean? Google is not a typical enterprise. For example, Google doesn't have LDAP. There's no LDAP. They didn't care or bother to think about building an LDAP in there. Google doesn't really have that many different roles and access levels and all that stuff that they've built into the cluster. But for OpenShift, when we take Kubernetes to an enterprise, this is the first thing on the mind of an enterprise architect. Security, role-based access control. When we talk about developer self-service and all that stuff, you absolutely have to have multi-tenancy. Enterprises want to use LDAP and they want to use all these different tools that they expect. They expect it to be secure. They expect it to be repeatable builds and all this stuff. So that's what the value that Red Hat brings with OpenShift on top of that. OpenShift is an open source community. OpenShift Origin is the upstream open source community. OpenShift Enterprise is the version we support on-prem by enterprise customers. And when I say on-prem, I mean managed by that enterprise customer. So you can run it on-prem if you want. You can run it in AWS, EC2 if you want. You can run it on any cloud or multiple clouds or however you want it. But it's basically how do we take Kubernetes, harden it, make it enterprise ready, and we'll run it. We'll run it somewhere. We also have an option where we'll run it too, but OpenShift Enterprise is the on-premise option. So how do we, honestly I have no idea what that slide is. Okay, so how do we talked about integration. We talked about a little bit of a high level about Docker and Kubernetes. Now how do we bring all that stuff together? Now this is, at Red Hat we have a product called Fuse. Who's heard of Fuse? A couple people. So Fuse, if you look at our marketing on our website, and I don't know why they do this, but it labels Fuse as an ESB. And with Fuse, we've had Fuse for 5, 6 years now, and I came from FuseSource. Fuse has always been, how do we build integrations, but not like how you would do it with Data Power, OSB, WASI-SB, and all of the big heavy vendors. And so from that standpoint, I would look at it as Fuse as Apache Camel, CXF, AMQ, ActiveMQ, all these components that you can use to build distributed systems, but they don't have to be in this monolithic enterprise service bus layer. They can be distributed out with your apps. So just like we talked about Camel being a Java library, we encourage people to build out your applications as isolated distributed systems, not as here just munge everything into a ESB layer. So Fuse with Camel, ActiveMQ, CXF, and whatever JVM you want to use, what we've brought to the table with that is a handful of Docker images, Maven plugins, and this I really like is the container development kit. When we talk about building and running microservices locally on your machine, how do you run 10 microservices that all listen on port 8080? If you run them in Docker containers, they can all listen on port 8080 without colliding. But if you're going to run them in any sort of scale, you're going to want some sort of cluster management, Kubernetes being an option. And what the CDK is basically is a VM that lives on your developer host, whether it's Windows or Mac or whatever, and has Kubernetes running and Docker running in it. And when you build your applications now, you're building them as Docker images, and you're deploying them into the CDK. They can all listen on port 8080, they can all listen on the same file location on the file system. There's no collisions, there's isolation. And now when you take these components and move them into QA or dev or whatever, they're running in the same cluster management solution that you have running locally on your laptop. And let me show you an example of what that looks like. So if we come back here to the command line, we have the CDK running, which is a Vagrant and VirtualBox combination. So we use VirtualBox as the VM provider and Vagrant just to spin things up. You guys have heard of Vagrant? VirtualBox? So I have, so if I pull VirtualBox up, you can see I do have the CDK running locally on my machine as a virtual machine. When so inside of that is OpenShift. OpenShift, like I said, is a production enterprise-ready Kubernetes, so we can run all the same Kubernetes commands, like get pods. We don't have any pods. Remember I said pods, like Docker containers. But what we're going to do is I'm going to do a Maven. Don't worry about these Maven profiles I have here just yet. I have a lot of different Maven profiles in here because I use this demo to do all kinds of different things, so I can put all the different pieces together here. Hopefully that it works. We're going to run Docker build from a Maven as a Maven plugin, which means we don't have to go find or build the Docker file ourselves and get the right context and build a Docker image by doing Docker build, yada yada. We're just going to plug into our existing workflow, that Java build tools with the Maven plugin here, and then we're going to use another Maven. No, let's skip that. Let's do that. So when I am in target directory there. So I'll let that build for a sec. As part of the Fuse integration services, we're running basically Camel stuff that we saw. We can run ActiveMQ and a bunch of other stuff too, but we'll just look at Camel. We have this set of Docker images and the Maven plugin, so we're going to be looking at both. The Maven plugin here builds our Docker image, and it built it locally, and since we're connected to the CDK, that Docker image lives inside of the CDK now. So if I do Docker PS, we should Docker images. We should see our Ryver auto res, which is the application that I just built, created a new image. Now, if I want to run this inside of Kubernetes, Kubernetes has a YAML file or JSON file that you describe what containers you run, which replica controllers you have, how many replicas, which services you want to deploy. All of that stuff has been automated with Maven plugins. So as part of our Maven build, we can just generate all that stuff on the fly. We don't have to try to hand hack that. We can just do, I think it would just do that. Default, we'll build that JSON file for us. So here's all that JSON. I mean, don't worry about the details of it right now, but just be thankful that you don't have to write this yourself. So now that we have that file with another Maven plugin, apply, we're going to take that JSON file and send it to Kubernetes and say deploy this manifest file, which has our Docker image and all that stuff configured. If I do get pod, we should see now that our Ryver auto pod has been started. If I do get replica controller, we can see the replica controller was installed. Does it show the number of replicas? Yeah, 1. Now, if I want to scale this application up, I can just do scale rest to replicas. Say we want to do 3. Yes, pod. Now we should have 3 of those REST services. There's also, Kubernetes has built-in auto-scaling, so you can say, well, if CPU threshold gets to 50% on one of these containers, scale up by factor, whatever. And then if the load goes down, then just scale it back down. Or you can manually do it like this. Are there any questions about that part? No? Okay, let's switch gears real quick. I've got 5 minutes left, and I want to show you real quick we didn't talk about Fabricate, but I want to show you, Fabricate is a community that builds lot of Java developer-focused tooling on top of Kubernetes and OpenShift, including stuff like continuous integration and continuous delivery. So with Fabric here, we can take OpenShift and we can take our applications and have a very customizable pipeline that allows us to do promotions of code from environment to environment using things like Jenkins and Jenkins pipeline, plugs into Nexus and our Git repo and do all that stuff. Is that all right? Do you guys want to see that, or? Yeah, maybe. Let's see. So let's take this down. Take down the CDK. We'll bring up another one. So Fabricate's an upstream community that built on top of OpenShift, but so I'm going to be using full community stuff. No product stuff, so I'm not going to be using the CDK for that. But it's still just another vagrant VM. We'll give this guy a second to come up. Usually it comes up decently fast. What we're going to see is I'm going to create a new project inside of OpenShift Kubernetes from scratch. I'm going to build maybe a Camel app or a Spring Boot app. It doesn't matter. I'll pick one in a second. But what that's going to do is actually create the Git repo for us. We can choose an existing project. We're going to create one from scratch. It's going to create a new Git repo for us. It's going to create a new Jenkins pipeline job for us. We're going to choose the type of job we want to be able to do. We want to be able to do a deploy and have approval steps in between. Because although it's really nice to think that you're going to push things from each individual commit directly into production, that's not realistic. In any environment, but in a traditional enterprise especially, you're going to have gates. Certain people are allowed to approve and check things out and make sure that things run in QA and so on. So, in here, local vagrant. Again, this is OpenShift, all upstream stuff. So we saw how I ran that REST application, and it had a replica count of 3, and we have those pods. If we look inside of this default namespace, click on runtime, and click on pods, here are all the pods that I'm running on this VM locally on my machine. So like I said, if you're running microservices, you might have a lot of stuff running on your machine. I've got Elasticsearch and Fluentd and Grafana and Jenkins and Nexus and all this stuff running. Happens to be on this VM, but what we're simulating is running this on a cluster of hosts across, it doesn't matter where they're running, but you get this unified dashboard of all the stuff that's running. If I click on, let's go back here to default, and click Create App, give it a second. Replica controllers, I see something. Jenkins kind of takes a second to start up, but we can see all these other pieces that have started up. So if I go to Gogs, is a Git hosting repo that implements the GitHub API, so we can just swap out to GitHub if we want it pretty easily. If I go to you can see Gogs running here. We don't have any repositories. Is Jenkins up yet? Yes. Create app. Set up the public key real quick. Create new app. All right, now we're going to choose the type of app that we want to demo here. Since Docker and Kubernetes are they're not very opinionated about which technology stack you use, just something that has to run on Linux. We could pick Node.js, we could pick Rails or any or Python or whatever. We're going to pick a Camel app, give it a name called demo, and say next. And behind the scenes, like I said, this is going to set up our Git repo. It's going to set up our Jenkins pipeline based on the one based on the pipeline that we'll pick here in a second. So you can have libraries of different pipelines. You can say for certain developers you can push directly into production, I guess, if you want. Or you can say, no, you can only push into dev, and then that has to go into QA, and then somebody else has to look at that, approve that, and so on. So you can have these libraries of pipelines that push into different environments. In a little while, here we go. We're gonna pick a pipeline that that allows us to do promotion. And click next. Give that a second to go. And now the UI here is going to show us all the different environments that we have, the version of the app that's running in those environments. It allows us to click to see what git commit caused the version to run that's running in that environment. Let's give it a second here. If I refresh the git dashboard here, we should see some git commits were created, click on repositories. Here's the source code for our application. When we do a build, we're going to use the same Maven plugins to build the Docker images, to deploy it to Kubernetes. It might take, so it's starting to, it'll spin up a new build in a different pod. And it might take a second to start up. But are there any questions? Totally ran out of time here. I totally blew over the fabricate stuff. So this is something that exists in the community, and we're looking to bring this sort of functionality to OpenShift. We can OpenShift.
Is this fabricate utilizing OpenShift?
Yes, it's built 100% on top of, well, Kubernetes. It is built on top of OpenShift in this example, but it's
This
underlying
is V2
of
fabricate?
yes, V2. Yeah. Here we're doing something. Downloading.
Ready for prime time?
I think the concept is. I mean, this was built as a. What would this really look like? How would you really do CI/CD? Because everybody talks about it, and we, how do we? The problem is, a PaaS can come in and say, here's our way of doing CI/CD. And you could say, well, that's awesome, but we have Jenkins, we have Nexus, we have all this stuff, we have a Java developer's point of view on all this stuff. How do we make those two worlds exist peacefully and properly, right? You want to take advantage of your existing investments and build an automation, all that stuff. So this is how do we do that? It's a working demo, and we're working, and the community is coalescing and building around us. How do we actually do that in a Kubernetes world? How do we use Jenkins? How do we use Maven? How do we use Nexus and Git and all these things without disrupting your entire build chain, build system? But as we start to build this out into OpenShift, then it'll be ready for prime time. And that's the path we're going right now.
So, in the development environment, will each developer have their own fabricate, or how do we set it up? Is it development environment, test environment? How do we set up these Kubernetes?
So since OpenShift brings role-based access control, we can have a multi-tenant as a service type CI/CD system that under the covers may use a single Jenkins and may use multiple different Jenkinses. It's not, a single developer wouldn't know that. They would just see, here's a CI/CD system as a service that runs on top of Kubernetes. Is that what you're asking? So it would be multi-tenant out of the box.
I see one fabricate installation for tenants.
One fabricate installation per OpenShift cluster. Yep.
That was developer has the
So how you break up your dev, QA, prod mirror, stress tests, and production, all that stuff. For example, at Google, there's not multiple clusters of Borg, there's just Borg. And it runs, if you want to run integration testing, you run it in a different namespace, really, an isolated namespace from your production apps. But on the machines on the physical machines that are running the apps, they're containerized and they're isolated from each other, so they run them together. In an environment or in an enterprise, they might have a little heartache about running testing stuff in the same boxes that are running production. So you can totally do it. This with the demo showing everything, testing, staging, production, running all within a single OpenShift cluster. But you could split them up so that testing is its own OpenShift cluster, staging is its own, and then communicate by building Docker images and swapping Docker images between each other. Oh, so let's show that this actually does go to production. So it sits in the wings. And at the bottom. And the approval, I'm doing it right here in this UI to make it easier, but the approval could go through whatever approval processes you have right now. Maybe you have a ticketing system, or maybe you have a chat system that operations folks are listening at. But so the approval process is just sort of webhook style integration with the system for approvals. Any other questions?
You make it look so easy.
It's so easy. But so this is the kind of stuff that I think we as a industry, Red Hat and its competitors and so on, we're trying to move toward. This isn't the bullshit PaaS stuff that you can just deploy in Node.js and it looks cool. But how do you build a set of self-service tools for developers to use to deploy and manage their applications all the way up into production, the same way Amazon does, the way they built out their tool chain, although we're building ours on Docker and Kubernetes, and that didn't have that back. All right, well, thank you guys for sticking with me. Man, that was long.
Okay, let's go ahead and wrap it up. Is there any one final short answer question?